So this screencast is about adjoint surfaces. We typically don't deal in these too much, but we've had some requests to show how you deal with brachys, adjoint surfaces, and how you run them in CFIT. So what we'll start with is the web page. And so if you go to Ken Brachy's web page, you'll see something on adjoint minimal surfaces, and it'll explain, what's going on here. Triply periodic minimal surfaces, you can go to this one as well, and this is where you'll find the adjoint surfaces CMD file. So if you download this file and you put it in the same directory as your FE files, when you call certain functions, it'll be able to find this file and it'll be able to run what's in it. So you want to download the adjoint.cmd.txt. You want to put that in the same location as your FE files, and you want to remove the txt extension. And so if you do that, you'll be able to run several of these cases that have ADJ in them. So ADJ here, so you can run this case. The other cases you can actually run without that script, I believe, without that CMD file. But I'm going to show you how to do that real quick in CFIT. So let's pull up the screens. Oops, let me close this out. Bring it all the way back up. And right here I have a couple. I'm going to close those two, and then I'm going to open up that hybrid one. Okay, so we have the file. And we can look through it and kind of see how it's defined. But we can also scroll to the bottom. And so one of the things about a lot of the Surface Evolver CFIT files, or I should say FE files, is that they have a lot of commands at the end that you can look at. And so they have GG, and so you have a comment here, good evolution, gets lots of facets near vertex 2 cusp. And you scroll down, you have calc that does something. You have reading in this adjoint.cmd, and so this is where it reads it in. And you also have ADJ, which is the command to run a joint. Frame, that does some things. And if we continue down, you'll see how to generate cubelets or cubes. Repeating patterns, I should say. So a lot of times what these files will have is what's called a go command. And that'll generally do everything for typical evolution. So you have go, it does the GG, ADJ, frame, show trans, etc. And so if we run that, let's first open up that file. That was the hybrid one. And so if we just hit go, it'll do its thing. And there we go. And so it doesn't look like what's on the website, but it doesn't look like that because we haven't performed the other functions. And so let's go back to this, and we could do show cubelet, that's a 1/8 unit cell, or we can show cube, and that'll give us a full unit cell. So show cube, and there we go. We get this complex geometry. And right now it doesn't look too great, so we can do a little bit of manipulating here. Let's show edge color. So for fixed edges, let's turn that off. -1 is transparent. And then we'll go to not fixed edges, and that's just choosing not fixed edges. Then we'll type in -1, and it'll get rid of those black lines. And so now we have the geometry. And this is how you generate a cube based on that the surface previous. And so it repeats. And so another question we had is, can you export these as an STL? So you can go to export STL, and we'll just save it in that same directory, adjoint files. So let's call it adjoint STL, and hit save. And let's go find it. And I'm going to open it actually in SOLIDWORKS. So what you find is it just exports one section, if you will, of the file. And now in a 3D modeling program, you can repeat this in any number of ways. What it's happening in CFIT is that it's rendering this section. This is a defined section, and then it's just showing how it's repeated in different ways. It transforms it. So you can export, the a component of the full structure. And like I said, in the solid modeling software, there are ways to repeat this as you like, and then create full 3D models, and then do whatever you like with them, create sculptures or whatever it may be. So that is the quick outline on how you deal with these adjoint um, geometries. It just requires the adjoint CMD file for some of these cases with 80J in the name, and you can look at the tail end of the FE file to determine how you run it. And this is the same for all those cases, and if you just follow the same procedure, you shouldn't have any issues generating them. Well, I should say you'll be able to generate a lot of them because we've done that here. So if you have any questions, let us know, but that's how you do it.